Welcome to today's session on solving linear equations. This first one will be just using one variable, so just one letter. So we've looked at inequalities beforehand, exactly what inequalities are. Now we're looking to solve these in much the same way as what we do when we're solving equations. Throughout this we're going to be solving x, but just pre-warn you, it's not always going to be that case. So here's my first problem. I've got 2 is less than x plus 4. 2 less than x plus 4. So again, just like with my equations, whatever I do to one side, I'm going to do to the other. Or I can take one side to the other, so my inequality symbol, which will then turn it into its opposite. So a plus will become a minus, minus will become a plus, a multiplication will become divide, divide will become a multiplication, for instance. So if I subtract 4 from both sides, my 4 on the right hand side disappears. 2 goes on to, minus 4 goes on to the left hand side. So 2 minus 4, that becomes minus 2. So this is now solved. X is greater than minus 2. Here's another example where 3 is greater than or equal to 2x plus 2. If we subtract 2 from both sides, we get 3 minus 2 is greater than or equal to 2x, because this plus 2 disappears. So solving this, 3 minus 2 gives me 1. So 1 is greater than or equal to 2x. But just the same with equations, we are looking to find out the value of just a single x. So if we divide both sides by 2, our 2x becomes a single x. And now we've actually solved this where x is smaller than or equal to a half. We could get scenarios where there is a negative x. For that we've got to do something slightly different, but I'm going to show you 2 ways to approach this when we are starting a problem which we've got to solve where there's a negative x. So a negative number in front of the x, or some of you may know it as a negative coefficient. So here 2 is less than negative 2x plus 4. So the one way of doing this, I'm going to add 2x to both sides, because eventually I want to get a positive x at the end of this. So if I add 2x to both sides, my 2x, negative 2x on this side gets cancelled. On the left hand side I've got 2 plus 2x. Now I'm going to subtract 2 from both sides to remove this 2 from the left hand side. So 2x is less than or equal to 4 minus 2. So 2x is less than or equal to 2. So if I divide both sides by 2, because yet again I want the value of a single x, dividing both sides by 2, x is less than or equal to 1. Because bear in mind that anything divided by itself, so 2 divided by 2, always equals 1. Now I'm going to show the other way of doing this, where I'm not going to move 2x from this side. Something different will happen when I get towards the end. So I'm going to subtract 4 from both sides to remove my plus 4 from the right hand side. This becomes negative 2 is less than or equal to negative 2x. Now I'm going to divide both sides by negative 2, because I need a positive x on one of my sides, in which case, in this case, my right hand side. But anytime that I'm dividing or multiplying by a negative number, this sign will flip, will switch over. So it'll turn from a less than or equal to greater than or equal to. So dividing both sides by negative 2, 1 is greater than or equal to x. And this is the exact same solution as what we did, what we got from doing it the other way as well. So 2 different ways to approach these problems. We could get harder cases where we've got double inequalities actually happening. So here I've got minus 6, which is less than 2x minus 8, but this is also less than or equal to 4. Now again, there's 2 different ways to approach this. I'm going to show the first way, where I'm going to approach the whole thing all at once by doing my laws of equations. So if I add 4 to the middle, add 8 to the middle, I've also got to add 4 to the left hand side and to the end part, to the right hand side of this inequality. So this will become this long thing here. So minus 6 plus 8 is less than 2x minus 8 plus 8, which is less than or equal to 4 plus 8. And that simplifies to 2 being less than 2x, which is less than or equal to 12. Now I'm going to divide all of my terms by 2, because again I want the value of a single x. So that's going to become 1. 2 divided by 2 gives me 1, which is less than 2 divided by 2x, which gives me x, which is going to be less than or equal to 12 divided by 2, which gives me 6. And this is the end solution. So my x value is going to be greater than 1, but it's also going to be less than or equal to 6. But there is another way to do this where we can actually break this up into 2 separate parts. So I'm going to solve this part of the inequality, then I'm going to solve this part of the inequality, and then bring it together at the end. So I've got minus 6 being less than 2x minus 8. So if I add 8 to both sides, I get 2 being less than 2x. And then again dividing by 2 because I want the value of 1x. So I've got 1 is less than x. Now I'm going to deal with this side. Again I'm going to add 8 to both sides, which gives me 2x being less than or equal to 12. Dividing both sides by 2, halving both sides, that will give me x being less than or equal to 6. Bringing those two together, 1 is less than x, but x is also less than or equal to 6. And this is the exact same solution as what we had on the previous slide. But we can also show our solutions by using a graph. Anytime that we are showing solutions using a graph, so we'll end up with a line inequality rather than a line equation. We'll end up with a line inequality, but we're going to represent the line in 2 different ways. Anytime that we've got our strict inequalities, we're going to use a broken up line or dotted line. When we are using our inclusive inequalities, we're going to use a straight solid line, because this is going to tell us that along this line, this is actually part of the solution. When it's a broken up line, it's telling us that everything along this line is not part of the solution. So showing one for example, x being greater than or equal to 2, and that will look like this. Remembering a line equation for x equals 2, so you draw the line in for x equals 2. This will be a solid line because it's a greater than or equal to, and we're going to shade the right hand side of this. I'm also going to put my y is less than minus 5 onto here and shade everything below. Now you might be unsure about which side of the line to shade in, so I'll always suggest that once you've gone and drawn your line in, I want you to substitute in, replace, for instance for this, your y with a coordinate above and below the line, just to see if it fits. So for this instance, if I was to use 0, 0 and substitute that in for y, I can see that 0 is not less than negative 2, in which case I've got to shade everything below this line. And here's a little visual of all the different types that you can get. So if y is greater or equal to 0, I've got a solid line shaded above. If x is less than or equal to 0, I'd shade across the left, again with a solid line. So if you want to take a bit of a longer look at this, just pause the video, take a little look and see if the visuals help you understand more about inequalities with one variable. Thank you very much for watching.